Hello, this is Unit 4, Lesson 6. I'm looking at question number 5. It says a box with a square base. So let's see with my drawing skills. So there's my square base. Boom, 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 boom. All right, so let's call it X to be wild and crazy. It's going to have, must have a volume of 400,000. So, 44,000. So the volume is defined here. So we know that this has to be my constraint equation. All right. So this is the constraint equation. That's volume. Volume equals length, width, and height. I haven't even looked at the rest of the question yet, but I know 4,000 must equal length, which I don't know yet. Width is X. Oh, sorry, wrong order. Say length and width are both X. And the height I don't know because I haven't read the rest of the question, so let's leave it as 4,000 equals X squared H. Find the dimensions of the box that minimizes, so there's my optimization equation, the amount of material used, so that's surface area. So I am optimizing, so surface area is what we're trying to optimize here. Surface area would be, so the base squared plus, there are 4 sides, and I don't know what Smartboard is doing, plus 4 sides, which would be X times H, or length times height. I've kind of combined my variables here. This should really be, say, length and height, for example. All right, so let's put some variables in. So surface area equals, the base is X squared, plus 4XH. So that's what we want to optimize. Again, you want to drop down a variable here. So when I look at this one, I see H is by itself. When I look at my constraint equation, it's X squared. So I kind of want to avoid the square root while I can. So let's isolate for H. So height is 4,000 over X squared. So there is my constraint equation. That's what I'm going to use in my optimization equation. So surface area would equal X squared plus 4X, and then in brackets, 4,000 over X squared. That X will reduce that exponent by 1. So I end up with surface area equals X squared plus, now it'll be 16,000 to the X to the exponent negative 1. So the remaining X is in the denominator. I'm going to move it up top. So I'm going to take the derivative of the surface area with respect to X. So 2X minus 16,000 X to the negative 2. We're optimizing, so we are going to let change in surface area with respect to X equal 0, which means 0 equals 2X minus 16,000 X to the negative 2, or 16,000 over X squared equals 2X. Now I'm just doing some straight algebra. 16,000 equals 2X cubed. Divide both sides by 2. 8,000 is equal to X cubed. And you take the cube root of that. And if I'm correct, it would give me 200. All right. So that is my length and width. I can use that now to find my height. So height would equal 4,000 over 200 squared. So my height in this case would be, so the result with that would be 0.1. We're working in centimeter. And I know this kind of doesn't make some sense, so now I take a look back and I realize that cube root of 8,000 is not 200. It should have been 20, my error there, which means when I come up to this one, it's going to be 200 squared. It should be 20 squared. Oops. So 4,000 divided by 20 squared, that would be 400, so it'd be 10. So therefore, the dimensions would be 20 centimeters by 20 centimeters by 10 centimeters to optimize or minimize that surface area. If you have any questions with this, let me know and I'll see if I can clarify.